everyone, and welcome back to my series on work solutions for CSEC Add Math Paper 2. So we're on June 2024 and we have reached question number 5 and we're doing part A, and this question has to do with integration. So the region enclosed between the curve y is equal to x squared plus 1, the x-axis, the y-axis, and the line x equals 2 is rotated about the x-axis through an angle of 360 degrees. Calculate the volume of the solid of revolution that is formed, and this is worth 5 marks. Now, before we attempt this integration, it is important to know the shape of the curve. Now, sketching curves is not part of the Add Math syllabus, but if you know the shape of a general quadratic curve, you could actually sketch this curve and see what the region is that we have to rotate, and this will give you an idea of what the limits are for the integration. So the curve y is equal to x squared plus 1 actually is a derivative of the curve y is equal to x squared, which is a basic curve, quadratic curve that passes through the origin and is symmetrical about the y-axis. So this is a curve y is equal to x squared. So the curve y is equal to x squared plus 1 is the same curve, the same shape, but I move it up by 1 unit on the y-axis. So let me use a different color. So if I move this curve up by 1 unit, it will be a little higher up, so it will pass through, therefore, 0, 1 on the y-axis. So if we're looking at the region enclosed by this curve, the x-axis, the y-axis, and the line x equals 2, first we have to draw the line x equals 2, which is a vertical line that passes through 2 on the x-axis. So I'm just going to draw a vertical line straight up to the curve. So therefore, the region that we're looking at, enclosed by the curve, the x, y axis, and the line x equals 2 is this region here. Okay, so that's the region that we have to rotate about the x-axis. And we could see that our limits, therefore, will be 2, that will be the upper limit, and the lower limit would be 0. Okay, so our formula for volume of a solid of revolution about the x-axis is pi times the integral of y squared with respect to x. So let's substitute our curve. Y is equal to x squared plus 1, so we are basically squaring y before we integrate. And of course, I forgot to put in my limits, of course, upper limit 2, lower limit 0. Okay. So before we integrate, of course, we have to expand the brackets x squared plus 1 squared. So I'm just going to use the identity a plus b all squared to expand this the short way instead of using FOIL. So a squared, a will be x squared. So x squared squared will be x to the power 4. 2ab, so that will be 2 by x squared by 1, which will be 2x squared. And then b squared will just be 1 squared, which is 1. So now we have expanded our expression. So now we can integrate. Of course, we keep pi on the outside and we'll just multiply it by it at the end. So when you integrate your expression, of course, you put it in square brackets. So the integral of x to the power 4 is x to the power 5 over 5. Excuse my handwriting. Let me just write over that index. Integral of 2x squared will be 2x cubed over 3. And integral of 1 is x. And then we have our limits, 2 and 0. So let's evaluate this integral. So of course, if we substitute 2 first, our upper limit, we would have 2 to the power of 5 over 5 plus 2 by 2 cubed over 3 plus 2. Now, you notice if we substitute the lower limit 0 into the expression, we would just end up with 0. So if we evaluate this, 2 to the power 5 is 32 over 5, which is 6 2/5. 2 cubed is 8 by 2, 16 over 3 is 5 1/3. And we have plus 2. Okay, so let's add together 6 2/5 plus 5 1/3 plus 2 will give 13 and 11 over 15. And of course, don't forget pi. And of course, we would have our units. Since we're dealing with volume, it's units cubed. So this is our volume of solid of revolution.